Hello everyone. Again welcome to numerical series of utilization. And today our numerical problem is a train is required to run between two stations 1.6 kilometer apart at an average speed of 40 kilometer per hour. The run is to be made to a simplified quadrilateral speed time curve if the maximum speed is to be limited to 64 kilometer per hour, acceleration to 2 kilometer per hour per second, and costing braking retardation to 0.16 kilometer per hour per second and 3.2 kilometer per hour per second respectively. Determine the duration of acceleration, costing, and braking period. First of all, write all the given data. Distance of run, yes, 1.6. Average speed, B, 40 kilometer per hour. And maximum speed, that is B1, 64 kilometer per hour. Acceleration, alpha equal to 2 kilometer per hour per second. Costing retardation, beta C equal to 0.16. And braking retardation, beta 3.2. We know duration of acceleration, T1 equal to B1 upon alpha. So value of v, put value of v1 and alpha, you can get 32 second. And actual time of run, t equal to 3600, yes, upon va, ready, 3600 into 1.6 upon 40, 144 second. And let the speed before applying brakes, that is v2. Then duration of costing t2 equal to v2 minus v1 minus v2 upon beta c, that is 64 minus v2 upon 0.16 seconds. So duration of braking. Above is duration of costing and this is duration of t3, v2 upon beta, so v2 upon 3.2. And since the actual time of run t equal to t1 plus t2 plus t3, so put all this value, and after putting all the value, we can get v2 equal to 48.5 kilometer per hour. So the costing, duration of costing, 64 minus 80, this value is 80, 48.5 upon 0.16, that is 96.85 second. And duration of braking, t3 equal to v2 upon beta, so 48.5 upon 3.2, that is 15.15 second.